our session is titled Deep Tech, Expanding Horizons and Growth Potential for Space and Geospatial Industry. So it's my pleasure. I'm going to start with Anup. RMSI has been in business, in the business of geospatial data and solutions and production. So how do you see the role of deep tech in mapping and geospatial solutions, since you've been at it probably the longest of us?
Yeah, that's right. We started the company in 1993, and about 6,000 people across the world. We work in about 50 countries. And we're seeing a profound impact of these new technologies. So much so that within our organization, we've articulated a 3S concept, which basically stands for scope, scale, and speed. So the scope, the kind of problems that we're able to solve now, because of all these, what you call as deep tech, was just not possible many years back. So one great example of this is the advances in autonomy, right? And how we are able to use machine learning and then merge that with geospatial data sets and create altogether new application areas. When you talk about scale, we would before, try some new concepts at a very limited spatial scale, and then would be very limited in how we could expand that. Now that's all possible because of how we are able to apply these technologies. And the third is, the speed at which we are able to do that. So I'll give just a few examples very quickly, how we've launched a global impact forecasting system for various natural disasters. And in that, we have kind of created a whole technology framework, and also created data sets and real-time sensor data fusion, where we can do about a 3-day advanced forecast for floods.
So, Sandra, I'll move on to you. Do you think deep tech has empowered commercial space and geospatial companies to harness the potential, especially towards actionable insights?
Absolutely. I think that deep tech has enabled commercial space to have an impact. And I think they are helping to bring those solutions to the government. But I think those companies need to understand the needs and processes of the government as well. When I think about actionable, I think about decision makers, I think about warfighters, and I think about those informed decisions and how they need to receive that data and the accuracy with which they need to receive it. In addition to providing that speed that we really need in our particular space, we also need to understand the provenance of that data at that same speed. And so that there's a growth industry, I think, potentially in that, in really understanding you're providing this at speed, but that you're also making sure that that data is as accurate as possible so that I can make informed decisions, sometimes life or death decisions, with that data as well.
Fascinating. Yeah. Thank you. On to you, Rika. So what's your view on deep tech as an enabler of commercialization of space technology?
Telecommunications was always about communications and connecting people and connecting continents and communities. And that's still what we do. It's still an extension of communication, data, and intelligence. And so really what we're doing around deep tech and the role that geospatial and Earth observation plays in all of this is really intersecting a lot of the different strains and threads of how all of this comes together. So at NTT, we do a lot around private wireless networks, we do a lot around data centers, we do a lot around IoT sensors terrestrially. And so for us, geospatial and talking about digital twins is a way to do that. And so it's been very interesting to see how deep tech continues to be deep tech, but really what is more relevant, I think, is the intersection of all of these, not necessarily the cool deep tech, it's really about the intersection of that and working with industry to do co-innovation together.
Last but not least, we've got John from Environics. It would be great to hear from you the tech that's enabling your current business right now. I mean, you're talking about the huge amounts of data that you're processing.
The kinds of work that we can do understanding populations at a small spatial scale really helps us harness a bunch of information that we can have about humans that, frankly, in the current regulatory environment, it's hard to use a lot of the signal and the personal data about populations. But when we use those data in a geographic framework with de-identification and anonymization rather than just for the one-to-one purpose in the commercial sector, we can bring a lot of value to healthcare, to planning cities, to energy, and many other aspects of making people's lives better at the fundamental level. So I believe that everything that we can do in aggregating and harnessing data can make people's lives better on a day-to-day basis for ordinary people and can also help the business sector. So I just want to tell you a little bit about what we've done in Canada to bring together a very large amount of disparate, different kinds of data, to bring it into a cloud-native ecosystem and bring expertise about the end-use applications to be embedded in that technology. We take data from about 150 different sources. So we create patterns, you know, who goes where people frequent different kinds of facilities, who drives by the Costco to go to the Walmart, by using spatial analytics to model that data and harness it using machine learning and other kinds of statistical techniques, so that you can go into that system and you can say, if I put a store here, or if I open a clinic here, you can run models, you can run all kinds of algorithms in the background to get an answer in seconds because of the power of that technology, that GIS technology underneath. And finally, those users that might be in banking, or they might be in the municipal planning department, or they might be in healthcare, or they might be in media, they can get the answer without having that kind of data expertise. They're not data scientists. They just run something where thousands of reports and workflows have been built behind the scenes. We've always built moving forward to try to take some of the foundations of geography to the new technology in the web services environment and respond to what businesses need so that they can get integrated answers quickly. So that's what we do.
Thank you. Two things come to mind. The what's next. What's next in terms, what's the next deep tech or whatever tech you're exploring in your organizations? Or what's next, where are the sectors and domains or applications that are not fully tapped yet that we can tap in with the current tech and the future tech?
We're thinking about multi-orbit connectivity at this point, right? As we think about LEO, MEO, GEO, and how all of these things can interconnect. And when we think about the large data models that we need to start anticipating. And so I do think about this notion, which is in my mind very visual, of this digital mesh, visible or otherwise, that is really connecting the ability to take a lot of Earth observation, run a lot of the insights and analytics at the edge of space, and then being able to just send down what's absolutely necessary. And so those are some of the things that I think we're going to start seeing is more of this intersection of the geospatial world with other space systems and technologies. We're doing things around, in our R&D groups, around quantum technology as well. And ultimately, people like to think about the sexy topic of data centers in space. So the idea of, well, it's pretty cool in space, unless you're too close to the sun. But hey, the sun provides solar energy, so how can we fashion the idea of micro data centers in space, which is also something that sounds super futuristic, but there's some really great startups like Sophia Ventures and Lumen that are working in these areas. And at NTT, we are in the data center space, so that's something that we're super excited about as well.
Right.
I think the collection orchestration piece, especially with LEO, GEO, MEO. I'm an imagery analyst. A couple of other folks are out there as well. And that evolution between, where we were 25 years ago and where we are now, that distinction between, in our organization, folks who are the collectors and do the prioritization and understand that piece, and those who are doing the analytics, right, and making sense of all of that data, is getting closer and closer. One of the things that's great is that deep tech is fantastic. Just know that insertion is, it happens after the fact, and then it's introduced into our organizations, and we have to sort of backtrack and make it fit into the way that we work. So there's a lot of skill associated with that, but it's something that we're struggling with, and that others are going to be struggling with a little bit as well. So it's something I'm thinking about. How do we make those connections? What can we do?
That's great, thank you. So I'm gonna jump on your obsessed with the end user to give Anup the opportunity, because he has all these applications for the end users. So I think you could probably shed some light on the untapped potential.
Yeah, so one thing we were excited about is how the digital twin itself is evolving, right? So what it used to be more like a representation to a more intelligent digital twin, where the end users are interfacing with the data, with the technology almost seamlessly. And then that becomes kind of an environment where we are also able to capture data in real time and then use that as a data source and then process that and create new applications. So, and one of the key enablers for that is data. We need to find ways of how we can collect more data and also how we can collaborate with each other. There are various companies, organizations which have all kinds of data sets, but still it's quite a challenge to access and integrate and then do all kinds of analysis on top of that. Because essentially most of the deep tech technologies we're talking about, they're all being driven by large-scale data integration, analytics, and then insights through all of these different methods.
Sounds good. You have an opportunity here to ask for something. What are you missing? What do you want to keep doing what you're doing and then achieve this global vision? John, we start with you.
I believe that as a community, we need to take a stand around the legitimate use of anonymizing, de-identifying data about population movements, to use those data to plan cities, to design infrastructure, and that as a community we need to break down the silo between ourselves and the lawyers who will say, no, you can't do that. It's the data and the statisticians and the geographers that can help organizations use actual signal data that might be considered sensitive in a way that respects the populations that provide the data.
Last words?
I think that bodes a bit of fear for global communities, that we're moving towards isolationism, we're moving towards sovereignty of data, and that's the opposite direction that I think that we need to be moving towards when it comes to interoperability. And so I think the key word here is balance. I think vertically integrated solutions is great. We need to be able to find a way to be able to progress business and advance deep tech in a way that's also going to enable interoperability and global collaboration.
Thank you, and thank you for the shout out for interoperability. Sandra?
Kind of back to what I talked about before, just understanding the accuracy of the data, providing that transparency. If you have a percentage, right, provide that, and also provide, what would get you to a higher percentage, so that people really do understand where the data is coming from and understand if they're making a decision, what's driving that.
Fantastic. Anup?
We need to understand that even a local problem today has a global dimension to it. So what that means is more collaboration on data exchange, collaboration on various other platforms, to understand that even if you're dealing with a problem locally, the solution is not just limited to that area.
I'd like to thank our panelists. Thank you all.